In this video, I'm going to look at some more problems from problem set 5.2, specifically at problems 21 to 24, which are found on page 182 and 183. And now this is where you start using the heats of formation as a variation of Hess's law. And the first couple questions just kind of are getting at the idea that heat of formation happens under standard conditions, which is 25 degrees in 1 atmosphere, which is why that's mentioned as the conditions in number 21. And then the other thing is that it forms from elements in their standard state. So whatever would be their natural state at 25 degrees in 1 atmosphere. So your reactants have to be elements, and then your product is going to be a single compound that's forming from those reactants. So A, you don't have a whole reaction to look, 21, you don't have a whole reaction to look at, but they want to know which of the following does not have a standard heat of formation value. So these are all molecules that should have standard heats of formation value, and even elements have a standard heat of formation, even though it's 0. So the question is, which one of these is not in its standard state? Cl2 would be a gas under standard conditions. Iodine would be a solid and diatomic under standard conditions. Sodium would be monoatomic and a solid, but bromine, Br2, would be a liquid. So in order for this to have a standard heat of formation, it would have to be in its standard state of liquid. 22 is similar, only this time we want to know which of these does have a standard heat of formation equal to 0. So which of these elements is in its standard state? Hydrogen would be a gas, but its standard state, it would be H2. It would be diatomic. Mercury would be monoatomic, but mercury is a liquid at room temperature. Carbon would be monoatomic, but its standard state is not diamond, or we'd be making a lot of diamonds under standard conditions. Instead, its standard state is graphite, or sometimes you just see C solid. So the only one that's in its standard state is silicon, being monoatomic and in the solid state, or D. 23 wants to know which of these reactions shows an enthalpy value equal to the heat of formation. So again, as I was just talking about, heats of formation happen under standard conditions. So we're going to assume standard conditions for all of these. But it has to be elements in their standard state forming a compound. So letter A, even though zinc is in its elemental state and in its standard state, copper sulfate is not in its elemental state. On B, copper, sulfur, and O2 are all in their standard states, but CuSO4 aqueous is not its standard state. CuSO4 actually forms a solid crystal, so the problem is over here. C, I've got H2O and CuSO4, those are not elements. And D, finally, I have copper, sulfur, and oxygen, each in their standard state, and they're forming copper sulfate as a solid, which is also its standard state. So D, and if you're wondering how am I supposed to know aqueous is not a standard state, solid, liquid, and gas are the standard states. Aqueous is never a standard state. You have to add something to water to make an aqueous solution. Number 24 says write the thermochemical equation for the standard enthalpy formation of propanon, and they give you the equation for it. And now you don't have to draw this one out, but when you see this equation, remember this is a condensed structural formula. So if you wanted to visualize what it is, it would be CH3 connected to a C, which is connected to another CH3, and then the O has to be double bonded on to fill that carbon up. So that's propanon, something called a ketone that we'll learn about in chapter 10. And the constituents would be carbon in its solid or graphite state. It'd be monoatomic. You'd need H2 as a gas. And then you would need O2, which also would be a gas. And then to form CH3, CO, CH3. That kind of works there. Let me see if I can clean that up a little bit for you. CH3, CO, CH3. And so then I just need to go ahead and balance this, and I would need 3 here for the carbon. I need a 3 here for the H2, and I need a 1/2 here for the O2. And then it says, state the conditions which the standard enthalpy changes are measured. That's room temperature at 25 degrees Celsius, or you could express it as 298 Kelvin. And then it's 1 atmosphere, or you could calculate it in pascals or kilopascals, although I'm guessing 1 atmosphere is more familiar to most of you.